Hello. So my name is Jinan Modi, and after 5 days of intensive Google Kaggle AI labs, it's finally time to showcase those skills into a complete real-world multi-agent project. Today, I'm presenting Enterprise Ops Agent, an autonomous system that performs a full root cause analysis from raw production logs. But before I show you the solution, let me explain the real world problem with this project solves. Okay. So let's imagine that in the modern distributed systems, there are a lot of outages like generating hundreds and thousands of logs entries in minutes and seconds. And now the engineers must manually read those logs, correlate the events, guess the timeline, and debate the root cause and write the postmortems, all under the pressure during an incident. Let me walk through a real and a very good example of a real life corporate world. So suppose imagine at 0 to like 10 in the morning, the system fires an alert that API latency exceeded the threshold. After at 10:07, the another log appears at timeout connecting to the payment services. Then again at 10:27 a.m., customer reports that checkout is failing. And finally at 10:45, the system logs resolution system stabilized. So to the human eye, these are just the scattered messages. But during the outage, engineers need to answer these critical questions like which event actually caused the failure, how did the issue propagate across the services, what was the true root cause, and like what actions need to be taken immediately, and how do we prevent it from happening again and again. This manual process is slow, stressful, and error prone. So, yeah, this is exactly where I built the enterprise ops agent. So I would be sharing you the whole project and showing you each and every agents. Like there are 12 agents which I have created. It was a very good, huge project, but yeah, finally we are there. So as you can see, welcome to Enterprise Ops Agent. First, we need to upload the file. So as I click upload, actually it takes time because there are 12 agents. So I have uploaded a raw file, and this is the Excel sheet. As you can see, you can afterwards in the future, I can enable all the APIs like Datadog, Salesforce, or whatever the corporate the company is using. And it would be similar. So I have added the three columns, which is timestamp, message, source, and level. So timestamp shows as I gave you the example, then the message which came up, the source where it came from, and the level which level it is. Okay. So this is a raw CSV file. I have already uploaded for the time. Like we don't want to waste the time like rotating all because it takes like about 5 to 10 minutes to upload and calculate everything. So I uploaded that file, and as we can go to overview, you can see after getting into overview, the incident provides an instant summary, including the severity, the affected services, number of logs analyzed, and the top suspected cause. So you can see that it is critical, high customer impact, degraded the user experience. The category was into customer impact, and the confidential score was 0.23. So this is the overview of the incident which happened. Now, if we go to the insights, as you can see that timeline, yeah. So here the exact timeline is given that what which event and which what occurred at what time of event. So at 10:02 an alert was given, then warning, developer log, and the whole whatever the errors are thought. So that is indirectly classified into timeline, so it is easy for you to see and just look into the matter that what happened at what time. After going to it, we have the hypothesis, root cause of the reasoning. So as I click this tab, yeah, so the root cause was downstream dependencies or external saviors failure. So it will show the score like it was 0.9 or 1 is the highest impact. So from 0 to 1, as you can see, the fourth one, high customer impact and degraded user experience. The customer complained unable to check out, getting 500 error. So this is a root cause which is using Gemini 2.5 Flash, and which proposes detailed hypothesis explaining why the incident occurred, supported by the evidence from the logs. So it is basically a support evidence system the agent is doing in this hypothesis tab. And we can go to the similar incidents also. I would be showing you this, like let's take an example, like what are the similar incidents which can happen. So you can see that there are three according to our Excel file, normal Excel we have uploaded. So it is checkout API, then it was database connection pool exhaust, and in orders of DB, external DNS outage impacting the third party APIs. After this, we have one more feature which is called narrative generation. So this basically narrates the whole incident into a five category, like five questions I've given, like what happened actually. So I don't need to go to all logs and check that what happened, why it happened, how it was mitigated, and what patterns match previous incidents, and what the organization should focus on next. This is the main point which our model Gemini and the logic behind our all agents getting into all together. Like it's an agentic AI, like all agents of agents working together. Like there are 12 agents, and we are getting this incident narrative. This is a really good feature. And after narrative incidents, there is one more good feature which is called recommendations. So post incident revenue review, which is scheduler a post incident review covering the detection and quality. So this is basically like suggests the prioritized mitigation steps such as restarting the services, scaling the infrastructure, or checking the failing dependencies. So yeah, previously I showed you the narrative. So this basically gives a clear, generative, human-readable story of the incident, perfect for engineer, managers, and postmortems, like the people who do all the postmortems after getting the report. And the last one, the second last one, basically is a calibration. Now, what is this calibration? To ensure that trustworthy output. I can't say that my model is perfect or whatever I have logic I've used in all the agents is all perfect. But this feature calibration and confidence shows that mathematically adjust all probability scores to avoid any overconfidence. So as you can see that it rates from H2, H1, H3, H4, H5. So here I think the highest was H5 as per as my knowledge. Yes, it was high customer impact and degraded user experience, which was given a score of 1, raw score and calibrated of 0.261. And there comes the last feature, which gives also a contrastive explanation. And this feature is basically visualize how the failure progressed, like from initial trigger through the downstream degradation to the customer impact. What gave this whole incident and what was the impact on the customer. This level of transparency is extremely valuable in the enterprise operations. So this was basically the main feature. Also, it is considered because as you can see that H5, as I previously told, is the best explanation because it represents the most certain and direct outcome observed through the incident, achieving a perfect score. And why alternative hypotheses are weaker. So it compares with all other hypotheses, like H5 is the main reason, but why not H2, why not H3, or why not H1? So it compares and gives a proper hypothesis and the explanation. So this is this is a called to check our whole project, like what we are doing and what the result we are getting. So it is a evidence, like proof that our solution is really very good. So the conclusion comes here that the in the summary, after 5 days of intensive AI training, this project brings everything together, showcasing a multi-agent, like agents of agents, that speed up the root cause analysis, provide a readable, explainable insights for real-world production systems. And thank you so much for watching my submission for the Google Kaggle Agents Intensive program. And I hope you enjoyed exploring the Enterprise Ops Agent. Thanks a lot.